We'll give people a few more minutes to sign on, and we'll look at getting started.
Hey, Michelle, it's Julia.
Hey, Julia, how are you doing?
Good, bonjour. It's I was wondering if I can talk to you more later about this I guess air quality during COVID-19 times, because I have a building that's now the client asked us to run the HVAC 24/7, but a lot of floors are not occupied. So I don't know how, if there's anything I can suggest to the client to say, there's still ways to save energy and keep the air quality.
Yeah, because actually, other than paying a lot,
Right.
7, unless you're like a healthcare, you don't need that. You need a 3-air change after occupancy. That's required. They should really look at their filters, making sure they have like MERV 14 or something like that, and running 24/7. That would serve a lot more their purposes.
Right. MERV 14.
And by the way, if it has a makeup air unit, I have a client who wanted to put HEPA filter on a makeup air unit for COVID purposes. I'm like, well, I think we might have makeup that last time. I'm like, unless you have a lot of cross-contamination with your exhaust, makeup do not need additional filtering compared to what they have right now for COVID purposes. This is not where COVID comes in. Comes in with the occupant and can be remixed in a recirc type system. But it's not because somebody tells you to put a HEPA filter somewhere that you should put it everywhere. Makeup air, a case of where you should definitely not put that. If you put it, it's for other reason than
and COVID.
Yeah.
Okay, got it. Okay, so I'll I don't want to keep keep your time, but I'll talk to you more about this if you're available. Okay, thank you, Miguel.
Oh yeah.
Okay.
All right, JJ, over to you. I'll just actually, before you begin, I'll just let everybody that's online know we are recording this session, so just be aware of that, please. And we'll be editing the recording afterwards for 2 specific sections. JJ, over to you.
All right, thanks, Stephen. Well, good morning, everyone, and welcome to day 2 of the Energy Light program. This morning, we're going to start off with a session on boiler and steam system optimization and opportunities. And just before we get started with Michelle and Stephen, I will introduce you to our subject matter expert, Paul Ingham, who comes to us from Thermogenics. Paul is the Vice President of Sales and Marketing at Thermogenics. He spent 21 years with the organization. He now focuses on boiler room solutions and design while leading a team of engineers in both Canada and the U.S. And Thermogenics, it's worthy of note, is one of the few remaining Canadian manufacturers of steam, hot water, and thermal fluid boilers, proudly manufacturing them in Aurora, Ontario. Thermogenics sends boilers and auxiliary equipment throughout the North America healthcare sector, and Thermogenics also provides specialized boiler service and rental support. And Paul currently sits as chair of the Canadian Boiler Society, well versed on the topic of boilers and steam systems. He's vice chair of the Commercial Boiler Group at the American Boiler Manufacturers Association. Thermogenics has always participated in and supported the Canadian Healthcare Engineering Society, as well as the American Society for Healthcare Engineering, ASHE. And Paul regularly provides services and policy advising for the Ministry of Government, Consumer Affairs, and TSSA in Ontario. Over to you, Michelle and Stephen.
Michelle, I'm just going to jump in before you begin, just to point out to everybody that along the top of your screen, there's a view active. You can select the dialog to what you see. So if you view active cameras, you'll only see the cameras that are active. For those that are speaking, we'll have the active cameras. If you're not speaking, we'll ask you to turn your camera off, or if you want to ask a question, you can turn your camera on. And you can make the slides bigger and smaller with the little bar that sits between the cameras and the slides. So that'll give you the maximum viewing pleasure. All right, now over to you, Michelle.
Thank you, Stephen. So this first 45 minutes section will be on boilers and steam system optimization. And obviously, we talked last time about HVAC and recommissioning. Obviously, it does tie in, because the first thing you want to do when you want to optimize your system is really to reduce your load. So that should always be thought about that before reduce. I think, Stephen, in the pyramid, we always say reduce waste, then optimize efficiency. In this case, we're going to talk about both, optimizing efficiency, more efficient boiler, more efficient operation of the boilers. So first thing first, let's put things in perspective here. Boilers and steam system in healthcare, especially in hospital, when we talk about steam, are very large user. They're usually, if you look at the boiler plant, it's the largest energy user in healthcare facility. Long-term care, for example, would probably have more hot water than steam, based on my experience. Some of them will have steam, but still heating and the boiler, which would be hot water boiler, do remain, even in long-term care, the largest end use, making up 50%, sometimes more, of the total energy usage. And one very distinctive impact, a characteristic in a hospital, for example, is the large base load. You do use those boilers all year round. You have needs for reheat, you have need for steam, for sterilization, for dryers, for the kitchen. So it is used all year round, and it has a large, and actually I'm pretty sure in most hospitals, depending on where you're located, it will be the largest GHG impact for your facility, because it's natural gas. This is a little slide I just added. That's why you probably saw my screen, go to Stonehenge and back. Just wanted to give you a little clue for those of you who have access to their gas bill. You should, and you wonder how much goes to heating and how much goes to my base load. And if you're natural gas, or even if you're a fuel oil, draw a monthly chart of your end use consumption. And this is actually for hospital. It's a hospital in New Brunswick, actually. Thank you, Kate. The red line here that I draw that at the average of the summertime usage. And you can multiply that value, which in this case would be, it's very small, but it'd be around 3,000 cubic meter per month. Multiply that by 12, and that's your base load. Anything above that is really your heating related or your weather related consumption. So if you want to know very roughly my total gas consumption, how much goes to my base load, which is usually, like I said, kitchen, domestic hot water, obviously, and sterilization and the dryers, that will give you that split. And if you want to know how much can I save in heating, well, you take whatever's above that red line, and it will give you a total cubic meter. And it is, I'd say, the first thing you should know is how is it roughly splitting between that base load and that heating? Because if you are, 70% heating, you should really look at optimizing your heating component of what your boiler plant is providing. And if your base load is really significant, it's 70%, then you should look at, what's going on with my base load? Is it normal to be so high? In this case, for example, this specific hospital, they thought that their heating was by far their largest gas usage, and it was not. It actually, the percentage for heating, and I did not put the answer there, is 35%. 65% of their gas was used, and like I said, I want to say it's an estimate, but it is actually probably the better estimate you can get, other than trying to do a lot of calculation manually, which all of them are filled with uncertainties. So 65% in this case was base load. So when you know that, you can prioritize, how you're going to approach your boiler plant load. Say, okay, I know my base load is my big ticket item. I need to look at what is making up that base load. Is it normal to be so high? So just that, like the extra slide, just to show you how you can actually very easily get that breakdown and then orient your, I'd say, your measures, your approach to reducing that. And obviously, I'm not talking about the actual boiler plant efficiency. Paul may actually touch on that later on, because you can obviously improve the entire plant efficiency by improving your boilers themselves. So the ways to take through the boiler and steam system. Sorry? Okay, sorry, I thought somebody else. So what you want to do when you want to improve your efficiency, like I said, is minimize waste. First thing, what is your CFR? What's your current facility requirements? Are you overheating spaces? Are you allowed in some spaces to have setbacks? That directly links to your boiler plant. So obviously, this is the first step that you need to do. Making sure also that your controls are running properly. Wherever you have heat recovery possibilities, you try to take advantage of that. How you sequence your boilers will also have an impact. And actually I was going to say mostly for hot water, but actually that's true also for all the systems. So are you using lead lag when you have multiple boilers? It will depend on the load, how your efficiency varies with load. So if you've got condensing boilers, for example, you are very often, you should not use lead lag. You should try to synchronize the boilers as much as a turn down ratio will allow, because they're more efficient at partial load than at full load when you're talking about condensing boilers. So those are ways you can optimize. I talked about the setback. Use the BAS to do regular diagnostics, and there is the steam traps. Where if you have steam obviously is required in many hospitals. You have no choice. You have to have steam. So you can convert from steam to hot water for heating purposes, but there's other end uses where you have to remain with steam, and that means you're going to have steam trap. And steam trap maintenance is really important as soon as you're talking about steam, and also keeping the right pressure of the steam system. You try to use as low a pressure as is required at the end point where you use the steam. At the boiler itself, you want to look at, what is my excess air? Where excess air refers to how much air do you put in that burner in order to get proper combustion. If you have too much air, then we call that you have too much excess air. It does reduce your efficiency, but be careful that don't just reduce your excess air, because then you're going to run in other type of trouble. In order to properly control that, there are different, sometimes more expensive methods where you can actually dynamically adjust your excess air based on measurements. You don't see that in small boiler plant, but in larger boiler plant, you'll have those trim system that will dynamically adjust your excess air so you keep always at the proper match, and you can gain, like I said, quite a few percentage points on your efficiency. What's not written here, and I want to emphasize that, if you ask your boiler operator or your plant operator, what is the efficiency of my boiler plant? He's going to very likely tell you, oh, it's really high, it's 85% or it's 86%. He's going to read off the combustion test results. That is combustion efficiency. You have to be very careful. This can be very far from the actual annual efficiency of a boiler. So if you've got an atmospheric boiler, for example, you could easily get 82, 83%, 85% combustion efficiency, but your yearly efficiency can be as low as 60 or 65% because of the stack losses in an atmospheric boiler. So always be careful when they talk about efficiency. You want to optimize it, but you want to optimize the actual annual efficiency, not just the combustion efficiency. Other place you're going to look at in a boiler plant, like I said, is heat recovery. There's many possibilities for heat recovery, and you have to look through the different possibilities. Usually you need a specialist with you to identify where heat recovery is possible. Few things you also need to be familiar with when you talk about boilers. Here we're talking about, let's say, hot water boilers. You've got the standard efficiency, which we typically would, and it is not hard numbers, but the minimum is 80%. That's regulated minimum for gas boilers. You cannot buy one or, unless it's a used one. A new one cannot buy below 80%. So 80 to 85% would be considered standard efficiency. Then you got those mid efficiency, 85 to about 88. And then you got the high efficiency, the condensing boilers, and that's above 88% efficiency. If you see a boiler that has an efficiency above 88%, typically 90, 93, 95%, right away, right off the bat, you know it's condensing. The reason is there's about 12% of the energy in the flue gas, in the combustion gases, that is water vapor. And in order to get more than 88% efficiency in a natural gas boiler, you need to condense. So you're a condensing boiler, so you can capture that latent heat that's in the water vapor. And the other thing you have to be very careful about, you get more losses from that than you would do from optimizing your excess air, is short cycling. A boiler that starts and stops will lose significant efficiency because there's always purge cycle. You will actually lose significantly more if you have a boiler that keeps starting and stopping all the time. And there's, again, various reasons why it might do that. So you really need to have it looked at if you consider that it is short cycling. When you do a hot water boiler retrofit, be careful not to go for a same for same replacement. That's the last thing you really want to do. That's the, sometimes one in a lifetime opportunity, because boilers can last a long time if they're well maintained. So you need to make sure when you replace, look at your possibilities. Don't just, if you have, a 20 MBH boiler, just don't put a 20 MBH boiler back. Make sure your right size. Your load might have gone down. You may not need the same size. You may want to get a condensing boiler if it's for hot water. I'm not talking about steam here, but be very careful. Condensing boiler has 95% efficiency when the return water temperature is cold enough. You need a return water temperature that will be well below 133 Fahrenheit. 133 Fahrenheit is where condensation may start to happen in a condensing boiler. You need fairly cool water. So if your building, your long-term care, or your hospital was designed to supply 180 water, all the baseboard, all the coils are high temperature coils and baseboard, well, you're gonna put a condensing boiler in there and you won't be able to run at the temperature required for condensation. You'll be running very often at 160, 180 Fahrenheit. It's all in Fahrenheit. I'm not very good in Celsius here. And that means you will not achieve the promised savings. You will achieve savings compared to a standard boiler, but you will not be condensing, actually not all of the year. At least you may be in condensation in when the load is lower, but not when the load goes high. So be very careful about that. Right size your boiler, pick the right combination of boilers. You may want a condensing, you may want a mix of a condensing and a high efficiency but non-condensing boilers, depending on your application and how the system was designed. Just be very careful not to blindly buy condensing boilers because they're more efficient. The rest of the system is important. If you have a condensing boiler and you have low temperature loads, you try to serve those at the end. So a makeup air unit, for example, if it can be on the return, you send the water in the makeup air unit coil at last, that one will drop your temperature because that's a low temperature load. It's outside air, it's cold. It can actually drop that return to lower temperature to improve condensation for a condensing boiler. So it's, like I said, you have to think all those things through when you do boiler maintenance. Boiler replacement. Now we're going to talk about maintenance. Very critical for proper efficiency of the boiler. And that's when we say maintenance, when you have heat exchanger, because we're always talking heat exchanger. A coil is a heat exchanger. Inside the boiler is a heat exchanger. Both sides of those heat exchanger need to be maintained. You don't want, like you see here on those coils, those look like steam tubes in a heat exchanger. They're really fouled. They need to be cleaned. You're going to lose a lot of efficiency or effectiveness through that heat exchanger if you don't maintain it properly. And the way it's maintained, you also have to be careful. Those are fairly rigid fins, but some of them are more delicate, so you don't want to squish all those fins. So careful how you maintain, make sure it's maintained properly. And obviously, if it's that dirty, something happened to the filter, so you've got to, it's a whole system that you have to maintain properly. On the boiler side, you have also possibility of soot accumulation within the tubes, and you can have also a buildup of calcium or different thickness of buildup on the exterior of the tube on the water side if your water treatment is not adequate, and that will also drastically impact your efficiency. Here you have in the table how efficiency will be reduced if you have different thickness of soot. We do have a similar table. It's not in the slide for a buildup of calcium or other residue on the exterior side of your tube. So you got to be really careful with your maintenance. When you're thinking of a major retrofit, obviously, and we do have, I think in module 12, presentation of a case study, or actually we'll talk slightly about that, where they did convert a steam heating system in the hospital to a hot water heating system. That will achieve fairly large savings, not just because of the boiler efficiency, but mostly because of the distribution efficiency, where you control way better with hot water. Your modulation is usually much improved. Comfort condition can also be much improved. And there are exceptions where you have a really good steam system that can maintain proper condition, but they are more difficult and they have steam traps. And when you talk steam traps, we're going to see you talk about a lot of potential losses. So, but that's not a low cost measure. That's something you must consider as a significant retrofit. And Paul might see it differently. Is welcome to talk about that later on. But usually steam conversion, something to consider at the end of the life of the useful life of the system. Talking about steam trap, if you said, oh, it's okay, my steam trap were checked 5 years ago, that is not okay. They fail about 15 to 20% per year with a typical lifespan of 5 to 7 years. So that's something you have to do on a continuous basis. That's a periodic, and it's not every 5 years. If you use a heat gun or infrared gun to check your steam trap, not the best tool to do that. Ultrasonic, it's old mechanics would use a screwdriver and put the screwdriver against the valve to see if they could hear that if it was passing. The reason why the infrared is not always the best is because the hot condensate and the hot steam are very similar in temperature, and the infrared gun is not the best tool to diagnose a passing steam valve.
And a basic ultrasonic unit, Michelle, like this I have in my hand is about, I don't know, maybe $400 or $500. So they're not that expensive.
Yeah, it's definitely worth having. Thank you, Stephen. I'm checking the time just to make sure. I tend to run too long, and I want to leave Paul some time there. We talked about the stack economizer. No, we did not. With oxygen trim, I talked about. That's what will make sure you have the right amount of air for proper combustion of your gas. But that will be usually in fairly large plant. Hospitals could have those. And long-term care, unlikely to have this because the boilers are too small. Stack economizer, that's one way to recover the heat going out the stack by putting this heat exchanger in the stack that will preheat the boiler feed water. So again, typically seen in larger installation. And you can also recover what's called a blowdown heat. So the boiler has a system to clean its water. I'm oversimplifying here, but you can recover also some of that energy going down instead of going down the drain, which you often have to quench with fresh water. So you can actually recover some of that heat. So there's a lot of opportunities when you have a steam system for savings. But the steam, if you have to prioritize, start with steam trap. You have to have a good maintenance, preventive maintenance program for steam trap. Stephen, I believe you did that QSUM, did you?
Yeah, this is an interesting example where a friend of mine was actually working with a hospital and analyzing their consumption, and the gentleman from the hospital said, "Do you think this QSUM thing is valuable to me?" And so my friend said, "Well, let's figure it out." So they went through and they analyzed their consumption. So they developed a regression analysis you can see on the top left graph there, which shows the relationship between energy, in this case natural gas, and outside temperature. Now, obviously, in a hospital, it's more than just weather, but there was a pretty good regression arrived at. And so that was used as a baseline to then generate one of these things called a QSUM. We'll talk more about this thing later in module 12, 13 on tools. And a QSUM allows you to look at the cumulative sum of the difference between what you expected to consume using your baseline and what you actually consumed. And it was interesting because when they generated the QSUM line, they didn't, the person from the hospital actually couldn't explain why that line started to descend down on month 12. And eventually he went back and said, yeah, okay, that was when we installed the economizer. So this is evidence of savings from the economizer. Pretty dramatic savings, actually. But then it took him about 3 weeks to figure out what happened when that QSUM line went horizontal in around month 23. And what happened there was that the economizer needed to be serviced 1 year in. So they basically shut down the boiler, valved it out, took the economizer out, cleaned it, put it back in, right? And then restarted the boiler and didn't open the water valves to the economizer. And so there was significant lost savings. But had you been monitoring that, even on a weekly basis, you would have caught that. And that's 70,000 cubic meters of lost savings. So monitor, even after you've got this technology, good monitoring really pays. Back to you, Michelle.
Yep. And by the way, QSUM, I think Stephen's going to present how to do it. For gas, it's great because gas is usually a few end uses. So you got what I call clean data. It's not mixed with, lights and fans and all that. It is a tool to use when you're implementing efficiency measures on gas. So last few minutes before I give the floor to Paul. So I think we've talked about maintenance and steam trap, water treatment. Make sure you have good water treatment, like we said. Like I said before, if you do not, you'll end up with a lot of issues, which will reduce your efficiency of your system because there's going to be calcium buildup. There will be damage to your equipment. Other opportunities that are shown here with the quick payback, maintain steam traps, obviously. If you can reduce the pressure compared to what you're using right now, adding insulation. I've been in a lot of buildings where they have those covers on the different valves. When you have a steam system, those valves are really hot and you do get a lot of heat loss. So having those extra insulation is really good. Something we haven't talked about is condensate return. When you have a steam heating system, you don't actually use the steam. It's not direct steam use. It condensates into water. That water should be returned to your boiler plant so that you don't have to use fresh water that's cold. So you have this warm, hot condensate returning to your plant that is used as your boiler feed water. There is actually, here it shows a heat recovery calculator for a condensing economizer. So the same example that Stephen has shown. But I think I'm going to skip that one because RedScreen does provide you with some tools in terms of looking at steam savings. And there's going to be somebody later, is it today or on Thursday, talking about RedScreen. So you can go on that tool. It's an Enbridge tool, but RedScreen does provide you with a lot of potential for estimating the savings from boiler and for steam system.
The good thing about the Enbridge one is it deals with the condensing economizer, which isn't specifically dealt with by RedScreen. So that's why kind of a neat tool. So yeah, definitely worth.
Yeah, and it's available. It's free, so you could definitely use that. So that being said, I wanted to leave about 10-15 minutes for questions and for Paul. And I will actually pass. It's not trained. Sorry about that. Sorry, Paul. So I'm going to pass you the microphone, if I can say, Paul, and let you explain the different efficiency measures for the boiler rooms and in the healthcare that you've encountered, I know, many times over. So I'll let you go.
Yeah, thank you very much.
Do you want to be presenter? Do you have slides you want to show, Paul?
Sure, I have some reference material in case the questions come around. So by all means, if you want to throw me the baton. First of all, thank you very much for asking me to join. We've seen a lot of change in healthcare over the last 15, 20 years, in particular in new build. The state of healthcare. And, you know, it's difficult to pinpoint what is the lowest hanging fruit in today's healthcare market, because it's so vast amongst the inventory that's out there, depending on the age of your hospital and the usage. You know, heat recovery has been an important one that you touched on that I think is underutilized in the healthcare sector. It's important as a hospital manager that you identify what your steam usage is, and we usually distill it down into 3 buckets. So you will have steam required for humidification, you will have steam required for sterilization, in some rare cases still laundry, but that is significantly declined over the last 10 years. And then you will have some sort of heating requirement for the building. That can be steam to liquid phase through heat exchange, so that can be steam to hot water or steam to glycol if you're doing freeze protection. And the reason I note that is because if you look at your inventory of usage, in particular on the steam side, and more than 50% of your usage lies in the winter because you're humidifying the airstream using that steam, that is a 100% makeup water application. So in other words, no condensate is returning to your boiler plant for you to recover heat or the chemistry that you've invested in putting into that steam. So in those applications versus the cost of technology, there is some real opportunity right now to look at implementing very simple flue gas condensing economizers. Because you are now heating city makeup water, typically between 55 and 65 degrees Fahrenheit, you have a very low heat sink, which will condense the flue in your boiler stack. And that allows you the opportunity to preheat that makeup water for your steam boiler system and take advantage of much greater system efficiencies. It's important to understand your usage because some hospitals do have seasonal size boilers. And so when you invest in something like condensing economizer, you want to make sure you put it on a boiler that is appropriately sized for the season that you intend to operate it. It will have a big impact on your payback calculation from Enbridge or your energy provider, depending on where you are in Canada. But it'll also play a factor on the size of that economizer. When you get into condensing boilers or condensing economizers, and thus it becomes very expensive. So you're going to want to have a close look at your usage so you don't overspend on a condensing economizer or condensing boiler plant that you don't actually need. So those are a few things right off the top of my head that I have seen.
Paul, can I ask you a quick question?
Absolutely.
In the I won't say in the hospital, but let's say long-term care, do you see a lot of conversion to condensing boiler when it is not necessarily well suited for condensing boilers due to the size of the heat exchangers?
We see that regularly. Even in the instance where you have existing hot water boilers that are traditional, as you noted in the presentation, operating at a 180 degree Fahrenheit supply with a 160 degree return due to the design of those heat exchangers, We are routinely seeing retrofit to high mass condensing boilers that will allow for varying flow. When you change, again, the material of construction of that boiler into a stainless alloy, you get better heat transfer coefficients. And even if you aren't able to squeeze out condensing, you can typically pick up a number of efficiency points on its own. But by swapping to condensing boilers, whether from steam or from traditional hot water, you allow the opportunity to vary flow. And by varying flow, you can significantly open up the delta T's and thus reduce your return temperatures into something of condensing nature.
And do you
One note,
Yeah.
sorry, Michael. One note I should just add on that: if you are considering retrofitting from steam to hot water, the crux of that is where your pumping capacity in terms of cost exceeds the transmission of steam. We've seen more long-term care facilities that are spread wide versus a multi-story, where it makes more sense to put two small condensing plants in, because to distribute pumped hot water versus steam didn't make sense. Hot water was still the play, it just required a different approach.
Very good point. Thank you.
If I can just make one note about one of the most common issues I see in condensing hot water retrofit in the current landscape, it's this slide right here. Can everybody see that okay?
Yes, it's good.
So today we do everything we can to load match.
Yes.
BTUs out, we're going to try and put them in the exact same manner. That translates over to turn down, as you noted so well in the presentation, how critical turn down in a boiler plant is to match that load usage, especially as we transition between seasons. Condensing boilers in particular are usually multi-unit cascading systems operated in parallel at their lowest firing rates, which is good. That's where you're going to achieve these high changes in terms of turn down. Where are we here? Whoop. I'm just going to go back right here. So there you go. There's that, what we were talking about, how you want to get back into those lower temperatures. So as you turn the boiler plant down and you get up in the firing rates, you translate to greater efficiency. But as you look at certain boiler types, and this goes for steam, but in particular in hot water as well, when you operate at lower firing rates, you actually introduce excess O2. So that's the air required for combustion. Depending on the boiler make and style, you require excess O2 to get the flue through the pressure drop of the vessel, but it's also to protect the burner from impingement of that flame and degradation against the boiler plate itself where the burner houses. But as you can see by this chart, as you change the amount of excess O2 in your burner, which typically occurs at lower firing rates, you actually reduce the point in which dew point occurs in the flue gas of natural gas. So the number of hospitals we've been into, in particular brand new ones, that are designed around 130 degree F supply and 100 degree return, as you can see by this chart, if they're running anywhere above these O2 rates, you're not going to actually see condensing of that flue until you get down around 90 degrees. So it's important to understand the style of the appliance that you might be wanting to retrofit into an application and its performance on condensing, because we have had some very sad energy advisors standing by a boiler returning 100 degree Fahrenheit return temp with zero condensate coming out of it. And if there's no condensate coming out of it, you're at that 85–86% efficiency range. And those places were designed to be 90%. So there is about
the telltale sign. When you see that it's always dry, that means it's not condensing.
Yeah, and that likely has to do with incomplete combustion or inaccurate combustion setup. This is really, really common as hospitals or anybody are implementing condensing technology, or they're going to higher turn down burners on their existing boilers. I thought this was relevant to bring up because we get calls about it every day.
Absolutely, that's 100% useful.
Turn down is great, but it has to be true. And as you note with steam boilers and the suggestion of perhaps adding O2 trim is applicable only to certain appliances. Even big boilers, depending on the pressure drop across that appliance, like I'm talking large fire tubes, there's only so much O2 you can scrub at that point. So make sure you have a conversation with your vendors to ensure you're getting what you pay for. Is there any questions about any of that?
What's the, when you look at a plant that has O2 trim, would you see that at starting at what size typically would you see? Obviously, like you made a good point, it's not applicable to all appliances, but where applicable, is there a sweet spot in terms of size that you'd say you'd see that?
This is my personal opinion, but where I find you get a transition between economics and performance is probably around 12 million BTUs and up. And that is because, and it used to be higher than that, it used to be closer to 15 million BTUs. And the rationale is because the O2 in situ cells that come on these sensors are typically very expensive. They require calibration to operate properly, and they require certain maintenance visits to make sure they're tuned properly. So if you offset the cost of those versus the performance that you're looking to achieve, it's around that sweet spot now. I would say around 12 to 15 million BTUs is where, you know, these more cost-effective cells, less maintenance-intensive cells are now providing the payback versus the implementation cost.
Thanks.
Paul, it's JJ. We have a question on the chat line here. Approximately how great are the efficiency savings from reducing the pressure across the steam system, especially where PRBs are in many of the endpoint units?
That's a great question. I'm actually really thrilled it came up because that is circumstantial. It's going to depend on your system, but there is one very important maintenance related issue that has come up almost at every application I've seen. Most boilers, in particular systems with multiple steam boilers, will have a stop and check non-return valve located on the boiler. The purpose of that valve is when a boiler is sitting in standby and offline, that the steam doesn't backfeed into that offline boiler and pressurize it. Those valves need a 50-pound differential to seal properly. As you flirt with less than a 50-pound differential, you get chatter on that valve. If that valve chatters and the seal fails, you will get condensate filling your offline boiler, leaving it locked out in high water and a potentially dangerous situation. The number of hospitals that have played with reducing their steam pressure and run into 3-4 times a year very expensive valve replacements and potential downtime issues has been staggering for us. And so while I think there's room for 10 to 30 PSI drop in many hospitals out there, be very, very careful to not just randomly drop 50 PSI because that's just what one of your users can get away with. There are going to be system issues that occur from that, and those maintenance problems will cause you headaches and money to offset the savings of that fuel. The only other thing too, JJ, is steam traps sometimes will operate inaccurately depending on the pressure differential across them. So I know Enbridge has a strong incentive for that. There's a lot of people here that have to deal with maintenance, and that really is our time and money. And so if you want to implement something like a pressure reduction, look at it from a maintenance perspective first and understand the impacts from some of your vendors. Talk to the trap survey guy, talk to your steam specialties group in terms of what impacts that turn down might have on the wear and tear of your system. That's the unspoken downside that we're seeing every day.
Would you say a 20 PSI would be more typical of what you would like to see?
Yeah, I mean, a lot of hospitals were running higher than they needed to. I'd say 120 psi, 125 even. Many of those are coming down to operate around 100.
100, yeah.
Depending on the boiler style, on the back end of that stop check valve, you can easily achieve high differentials. Some of the stuff like we manufacture, just because of the intrinsic nature of its design, depressurizes very quickly, but then repressurizes quickly. And thus, if executed properly, you can maintain that 50-pound differential and avoid maintenance issues on the valve.
Well, that's great insight. Thank you.
And Paul, you mentioned Enbridge and their incentive program. Are you having some good luck with their incentive programs and some of the projects that you're doing?
Very much so. We have been a big supporter of Enbridge as a large consumer of natural gas and fuel. But no, they do a great job there. I highly recommend everybody be regularly involved with their team. They'll often steer you in the right direction for other incentives, provincial or municipal, even for power savings as it relates to gas consumption. They're usually tied in with other energy modelers. And, without talking too much, because I could talk a lot, one big thing that is going to come through that every one of you will see, and it's typically driven by a populist demand, when you condense the flue gas of a boiler, you also condense gases like CO2 and NOx. And so you will soon find there'll be incentives to reduce your emissions. And condensing economizers and condensing boilers are great avenues for significantly reducing those emissions from your flues and your exchanges of energy.
Good point. Good point. Is there someone that specifically deals in healthcare with Enbridge, or is it sort of random across the province?
So I predict you will see that come through very soon.
Yeah.
Lucrative incentives to capture.
Oh, that's great. Very good. Does anyone else have any questions for Paul, or Paul, is there
Did that come
anything
through okay?
else?
I had a little glitch.
Paul, is there anything else that you'd like to share with the group?
Can you hear me again now? I had a little glitch there, it looked like.
Yes.
Yeah, your camera dropped out.
You got me
too.
okay?
Yeah.
Yeah, I did that just to try and stabilize the connection. But the only other thing I'd note, and it's fundamental, is do keep on your water treatment. If there is anything that's going to hurt your maintenance and your efficiency, it's going to be hardness and improper water treatment. And so, from a fundamental standpoint, while you're checking your traps, water treatment's really simple to just keep on. And I'd summarize with
Hardness.
that.
That's the word I was looking for, Paul. I could not remember how to say it. Was hardness. Thank you.
Yeah, no problem. Yeah, hardness is a killer for sure. It'll fail an economizer exceptionally quickly. The economizer in your system is the sacrificial anode, and because they typically require a constant flow rate, they will scale up in a few hours if you allow hardness to pass. If you had a softener failure, you can have economizer failures very, very quickly. And if you identify scaling an economizer after it's failed, you're gonna want to open those boilers up very quickly and make sure they're okay.
So, Paul, I think everybody is really appreciating your insight and your wisdom here. We've had a couple of people that asked to be able to get in touch with you directly. So, do you mind putting your email address and phone number into the chat there, and then folks can contact you?
Yep, no problem at all. Happy to help. And
there's one hospital that are potentially concerned about the issues you've talked about, and they need your help, I think.
Yeah, happy to help however I can. As JJ alluded to in my introduction, I'm heavily involved with the regulators as well as through the Canadian Boiler Society, so that's national. So if you need help with regulation or incentive, I just want to provide good guidance to the team so they can make good decisions. So happy to help.
Sounds good. Any last minute questions for Paul from the group? Seeing none or hearing none, I want to thank you very much, Paul, for your insight. It's always tremendous to hear from the people that work the front lines in these different systems, and you're definitely a very knowledgeable person when it comes to boilers and steam systems.
Thank you very much, JJ. Appreciate it. Thanks everyone for having me on.
Thank you, Paul.
Thanks, Paul.
So, moving on, we're move on to the next schedule, which is motors and pumps, and that's always a subject that's a bit of a mystery to us all. Just when we think we know all there is to know about motors, there's more to know. Unfortunately, we did have a subject matter expert from Armstrong Fluid Technologies that was going to join us this morning. However, they've had an emergency come up, and so they are unavailable. So we'll carry on with our subject matter experts, Stephen Dixon and Michel Perron.
Great, thanks, JJ. I'll take the lead on this one, and as Michel said to me earlier, he's going to do the color commentary. Thanks, Paul. You just, for those that are watching the chat, Paul just put his information